Hi guys, so today we're going to look at chapter 1, Essentials of Geometry. And specifically, we're going to look at 1.1 all the way to 1.4. So we'll be looking at identifying points, lines, and planes all the way to measuring and classifying angle. So let's get into it. First of all, looking at the essentials of geometry, let's just move right into 1.1. So identify points, lines, and planes. So first of all, just let's look at some key terms. So in geometry, there's the words point, line, and plane, and they're all undefined terms. So they don't have a certain set definition that you have to always follow, but it's kind of up to your interpretation to some extent. But where's like some kind of universal definition of the terms? First, looking at point, it has like no dimension, and it's just literally a dot. So any point just refers to on like just anywhere a dot. But where's a line? So line has like a one three dimension and it goes infinitely to both, in this case, the right and left side, and or other words to both directions. And it basically does not have an end, and it's just a one dimension. And you can just use like 2 points as shown here in this photo to kind of indicate that there's no limits, right? But second, let's look at like planes. So planes have two dimensions, which means that it's 2D. Like you probably have heard the term that, oh, this like figure is two-dimensional, and this is the same thing. Basically, a plane is hence the word two-dimensional, and it's represented by a shape that looks like a floor on the wall, but it doesn't have like an end. So you can see in this photo that like there's like no like here. You can see that there's a what we call plane, which is kind of like a coordinate plane, but it's just infinite and 4 points in it just to kind of show you what it means. But next, what are collinear and coplanar points? This is something that was quite important when I was doing geometry. So collinear points are just points that are on the same line. So if you're referring to say line AB, then this would any points on line AB like this would be collinear. Coplanar points are just points that are in the same plane. So a and B, this would be a coplanar point. But let's look at some examples. So if you just look at naming points, lines, and planes, it's pretty clear that, so if you give two other names for PQ, for the plane R, let's look at PQ, it's just here. Then you can also say like QP because they're on the same line N, and so on and so forth. And I think you can kind of like get these because it's just really the idea of collinear and coplanar, which is pretty straightforward, I'd say. But next, let's look at like some more important terms. So this is one of our basics of geometry, which is segments and rays. So since we already know what a line is, we can just basically know that segments and rays are a type of line to some extent. But the key difference is that for looking at segments like AB, segment AB, they have an endpoint, which means that it's like unlike a line which went on infinitely both directions, segments have endpoints and it's not infinite to both directions. And that's really the main difference for a segment. But ray, it's basically only one side is infinite. So it could be, in this case, the side for B or the side of A. So it's basically a line that goes infinitely to one direction only. But then what are opposite rays, right? Opposite rays, it's basically like if two segments and rays are it's like two kind of points like lie, like in this case, like point C lines on AB between A and B, then CA and CB opposite rays. So if you look at point C, that is between A and B, then CA going this direction and CB going this direction are opposites. And it's pretty clear because the arrows are going this way, which basically shows an opposite ray relationship. So I think you can get these examples. So I just want to kind of look at some terms and then do a couple of practice problems later. But let's look at intersection. So two or more geometric figures intersect if they have one or more point in common. And it's basically like if you think of the most basic intersection, like two linear equations, this would be like an intersection, right? That's basically what an intersection means, but it's not limited to just a linear graph. It could be a quadratic or an exponential or so on and so forth. So it's just not limited to linear, but it's just basically showing that two lines, two planes just intersect at one point or more than one point is what an intersection is. Yeah, so these are just example problems. So let's just look at a couple. So let's look at number 16. So line AB and line CD intersect at a point E. Which of the following are opposite rays? So let's try to draw this out, right? There's line AB and CD. Let's call this AB, CD, and this is point E. So opposite rays, using the concepts of like how you in opposite directions, let's actually draw this out because it'd be more simple. In geometry, it's like all about drawing. So line A, B, and C intersect at point E. So let's call this A, B, C, D, and E. Which of the following are opposite rays. Remember that because they're lines, they're going like this and like this. But if you want to show opposite rays, basically these, I think in this case, these two relationships, these two would work. But let's look at EC and ED are indeed opposite rays. CE and DE also are. And look, if you look at AB, but if you look at AB and BA, they're not opposite rays because they're basically the same line opposite. And if you look at AE and BE, yeah, it's also like if you look at EC, ED, and CE and DE, they may all show an opposite relationship, and basically C is just the one that doesn't work in this case. Yeah. And if we move on, let's look at like let's look at, for example, number 27. So from 27 to 32, you're given an equation of a line and a point. So you use substitution to determine where the point is actually on the line. Basically, you can use your knowledge of linear graphs, right? So 5 substitutes for 1, it substitutes for y, 5 is for x, and basically 5 substitute here, 5 minus 4 is 1, so 1 is 1, so we can see that the point is actually on the line. And that's basically it for section 1. I think this is really pretty straightforward. If you look at, now moving on to section 1.2 on using segments and congruence, I think here is where it gets a little more complicated. So if you look at geometry, one of the most difficult parts, or as people say, it's just postulates, theorems, and those kind of memorizing those to do proofs is probably the most difficult part of geometry itself. And the reason for that is because a lot of people have like trouble memorizing it. And this is, I think, the first kind of taste of it, although it's just the ruler postulate, which is not very difficult. So basically, a rule that is accepted without proof is called a postulate or axiom. Usually they call it postulate, but you can also know axiom. And a rule that can be proved is a theorem, which you will be doing a lot later on. Usually a postulate is just so obvious you don't really need logical reasoning to prove it. As seen here, like let's look at like the ruler postulate. The points on the line can be matched 1-to-1 with the real numbers. The real number that corresponds to a point is the coordinate of the point, and basically it's just talking about the name of and coordinates of points, which is pretty straightforward. And here, talking about the distance between points A and B, known as AB, a segment. The absolute value is the difference between coordinate A and B. It's just something that is so obvious if you look at how distance works. So I think that's really why it's a postulate, right? But let's look at postulate 2, which is the segment addition postulate. This is actually one that comes up quite occasionally when you're proving like certain theorems. But basically, it's saying if, let's say in this case, B is between A and C, then AB plus BC is AC. It's just basically, instead of adding like 1 plus 2 is 3, which would be just be the addition postulate, it's segments. So in this case, AB, BC is equal to AC. That's basically what this postulate is saying. For the sake of it, let's just look at example problems 3 and 4 before we move on. So use a diagram to find GH. First of all, GH is this value. 36 is the whole segment, and this is 21. So if you use what you learned from the segment addition postulate, 21 plus the segment of GH would be equal to 36, right? But to figure this out, you have to subtract 36 and 21, which is actually 15, right? So that means the value of GH must be 15. You can also use that ideology with the segment addition postulate by doing 15 plus 21, which is 36. But let's look at congruent segments before doing the last example for this section. So basically, congruent segments are line segments that have the same length. Basically, it's like the same thing as like segments that have the same length, but just to call it fancier, you just say congruent. So if, like, let's say AB is 2 and CD is also 2, then these two segments would be equal or congruent, right? Although congruent and equal are pretty similar, like in like theoretically. There's a huge difference between congruence and equality, and you'll see that later on while doing proofs. But it's just basically the notation that comes from it, right? Equal is just equal, and here it's a congruent sign and a segment is the key thing to notice. But let's move on to the last example for comparing segments for congruence. So if you plot the following points in a coordinate plane, then determine whether JK and LM are congruent. So here they actually plotted it for you already. So if you look at it, you're trying to figure out if JK and LM is congruent or not. So you can use the ruler postulate here, right? So when you look at 4 and 4 is already on the same like area. So you have to just look at the x coordinates, right? 2 and 2, -3. It's pretty clear if you just counted 1, 2, 3, 4, 5, then it's 5 here. Let's look at here. Because 1 is the same, you can apply the same knowledge. 1, 2, 3, 4, 5. So because both lengths are 5 at the end, you can say that they have the same length or are congruent in more fancier terms. And that's really it for this section. And you can just try these example problems by yourself. But let's move on to 1.3 using midpoint and distance formulas. Basically, the new thing here, I think most of you guys know midpoint from like algebra 1 or like prerequisite courses, but something that could be new is a segment bisector. But first, for the sake of review, looking at the midpoints, right? Midpoint of a segment is the point that divides the segment into two congruent or equal segments. So if M is the midpoint here, we could probably assume here is 2 and 2 or whatever value, which makes M a midpoint. But what is a segment bisector? So it's just basically a point, ray, line, or line segment, or point that intersects the segment at its midpoint. By bisect, because bis means two, we can assume that it's divide in like two in any way. So here, if we say CD is a segment bisector of the segment AB, then you can probably tell that the point where CD crosses is the midpoint of A and B. That being said, yeah. But let's look at like the midpoint formula. So this is something that comes up really often and is the base for like when you do things like when you apply the Pythagorean theorem later on chapter 6 and so on and so forth. So this is quite an important concept. But the midpoint formula, so you obviously have to memorize this or just know how it works. So the coordinate of the midpoint of the segments are the averages of the x and y coordinate of the endpoints. So I think this already shows the formula pretty clear. So if you're trying to find the midpoint of segment A, B, and A and B, then you just subtract y. You just first of all add the x values. So let's say here's 2 comma 3, then you have 2, and if here's for example 2 comma minus 3, theoretically, oh wait, this makes no sense. 2 plus 3, 1 plus 2, let's say, then you're basically adding the x points, which is 2 plus 1, which is 3 divided by 2, comma y1 plus y2, which is 5 divided by 2. So this would be your midpoint, right? That's basically how the midpoint formula works. Yeah, it's pretty clear as long as you know this formula, or you can solve it for the most part. But let's look at the distance formula. So this is another formula that is the base of many problems, and I think specifically this also applies to the Pythagorean theorem when you're trying to find like the distance between like points in a right triangle, for example. But you have to obviously know this formula. And the distance formula is pretty clear. It's only applicable in this case for right triangles, but like remember, it can just be used to find the distance between like figures, so like the points here and here. So it's not just for right triangles in general. But here, since we were talking about right triangle, we can just use it. So let's say you're trying to find the distance between point B and point C. As it illustrates, you just subtract x2 minus x1 and then y2 subtract by y1, but you have to like square it. So like if x2 subtract by x1, for example, is like 3, you square it, it becomes 9 plus, let's say here is whatever value gets 2, then 9 plus 4 is root 13. So the segment of the distance for AB would be like root 13. That's basically how the distance formula works. So let's just quickly solve this problem. So what is the approximate length of LRS with endpoints 2, S, 2, 3, and S as 4, -1? You're trying to find the length of RS. So it always helps to draw it out. So this is R, let's call this S. Okay, I don't know what's wrong with this, but basically this is the idea. Just remember there's a point here, but I think it's not cooperating. So R is 2, 3, and let's call here 4, -1. would be more ideal to put it in a coordinate plane, but for the sake of it, like since you can always see it, you can also think of it like this, although this is probably not like actually right. When trying to find the length of Rx, you have to use the distance formula. So 4 subtracted by 2 squared plus y2 minus y1, which would be, in this case, -1 subtracted by -3, which is basically squared, which is 4 plus, in this case, 16, which is root 20, which can also be simplified to 5 as the 4 comes out. So this will be basically your answer. Yeah, root 20 or 2, 5, 2 root 5 if you simplify. So that's basically the idea for the section. If you really want to get practice with like, let's say like segment bisectors or just getting comfortable with midpoint formulas and the formula, I suggest that you just practice these questions here because they're really helpful in like just getting really used to it because it can be difficult at first, right? If you don't really know the formulas. But let's lastly move on to 1.4 on measuring and classifying angles. So I think a lot of people do know what an angle is, right? A lot of people have heard about the right triangle, which has an angle of 90 degrees as one of its angles. But basically, an angle consists of two different rays with the same endpoint. So this is basically an angle, right? When you're referring to this angle, you can refer to angle CAB, for example. And basically, the rays are the sides of the angle. So this would be one ray and another ray. And the endpoint is called the vertex of the triangle of the angle. So basically, it's just like here. If you were to talk about let's say right triangle, like a right angle, then this would be like the vertex, and so on and so forth. So when you're naming angles, because this could be confusing at first, you have to always put the angle that you're kind of referring to in the middle. So what do I mean by this? So you're trying to refer to this angle here, then you have to say angle WXY because you need to specifically talk about this angle. If you were to say just angle X, it could refer to the whole angle here, not just this part. So it would be considered wrong. So you have to remember that whatever you do, you have to have an included angle. But if the case was like this, and if it was just X, you could just refer to the angle as X. But here, because there's a segment and there's a ray in between, you cannot just say that. That's basically the idea. But let's move on to our third postulate in geometry. So let's look at the protractor postulate. Basically, it's not really difficult, right? Because it's a postulate. But if you're considering OB and a point A on one side of OB, then rays of the form OA can be measured 1-to-1 with the real numbers 0 to 100, right? So measure of OAB is equal to the absolute value of the difference between the real numbers of like OA and OB. So if you're talking about the measure angle of AOB, which would be right here, then you're finding the absolute value of the difference between OA and OB, which would be here and here. It's basically what the protractor postulate is saying. I think that even if you don't really know trig or like are not that's not familiar with geometry, because you already have seen like these somewhere. And I think most of you know that in a triangle, the maximum number of degrees is 180 and so on and so forth. Yeah. So this is for classifying angles, and there's this for acute, right, obtuse, and straight. Acute angle is basically less than 90 degrees but greater than 0. Like it can't be like here. Well, that's negative angles, which you'll learn about later. But acute angles is basically just anything between 0 to 90, but not 90 included, because when it comes to 90, that's a right triangle, as you can see here. Obtuse triangles are between 90 and 180 degrees, as seen here. Maybe this could be 120 degrees, for example. But a straight angle is basically a straight line. 180 degrees is basically what represents a straight angle. Let's move on to our fourth postulate on the angle addition postulate. You already learned about the angle addition, the segment addition postulate. So I think this would be pretty similar for you, right? It has to apply to basically the same principles. Only difference is here you're adding angle measures instead of segment measures. So whatever value here plus here would lead to this value. It's basically what the angle addition postulate is saying. So if you're trying to find angle measures, I mean, let's just do this one for example. Let's say you're trying to find, what does it say? Find LKM, which would be right here, and MKN, which is here. So then you would obviously apply your knowledge here because it's given that LKN is 145 degrees. 2x plus 10 plus 4x minus 3 would be under 45 degrees. So if you just use your knowledge from algebra, 6x plus 7 is 145. 6 is subtracted by 7 would just be 138. And if you just simplify it, this will be 23 would be the value of x. But remember, x is not the value you're looking for. If you're trying to find LKM, you have to put 23 in here, and same for here, and whatever value you get, in this case of angle LKM being 56. And for angle MKN, it would be 89, so that would be your answer. But next, let's look at congruent angles. Basically, you know what a congruent segment is. It's when AB is congruent to, say, DC, right? So congruent angles is when two angles are just have the same measure. It's the same as equal to, but it's just for angles. Yeah, as seen here. Basically, AB and BC, let's say they're both 30 degrees, then they're congruent angles. It's basically the principle of congruent angles, just that they're the same measure. I think this is really it for this section. Oh, wait, last point before is the angle bisector. So it's just a ray that divides an angle into half. And if you like just bisect, let's say like here and here and here would be the equal. Because you have bisected it, means that you divided it in exactly half. And I think we already saw this with previous bisectors, so it's pretty clear, right? So basically, the idea for angle bisectors that you have to remember is this was, let's call YW an angle bisector, then they'll because bisecting in the midpoint, whatever side, like here and here, would be the equal measure. So if you're 30, here would also be 30 degrees, and so on and so forth. And basically, that was it for geometry, the first geometry lesson. I hope you guys enjoyed it, and I hope the things are really clear. And just remember to keep reviewing, know postulates, know the midpoint formula, distance formula. And next class, we'll learn about the describing angle pair relationships, and we'll learn more about complementary and supplementary angles and various types of angles. So thank you for listening, and bye!